You've seen the demos. Claude writes code, answers questions, summarizes documents, looks effortless. Then you try to build something real with it, and it hallucinates, ignores instructions, breaks on edge cases, costs you $400 in API calls, and works perfectly 0% of the time in production. That gap between the demo and the real thing is what harness engineering closes. A harness is everything that surrounds the model. Think of it this way. The model is the engine. The harness is the car. A Formula One engine sitting in a parking lot is useless. The same engine inside a precision-engineered chassis with telemetry, tires calibrated for the track, and a driver with feedback systems, that wins races. Every serious AI system in production is a harness. Claude Code is a harness. ChatGPT is a harness. Your company's internal AI tool, if it works, is a harness. Most AI projects fail not because the model is bad, Claude is genuinely excellent, but because the harness is broken or missing entirely. 6 layers. Every production harness has all 6. Skip one and you'll feel it immediately. Let's go through each one with real Claude API examples. Most developers write system prompts like this. You are a helpful assistant. That's like hiring an employee and handing them a post-it note that says do good work. A production system prompt is a constitution. It defines identity, capabilities, constraints, output format, and tone. It needs to be long, specific, tested against failure cases. Notice what this system prompt does. It gives Claude a specific identity, a rigid output format that your downstream code can parse reliably, hard constraints on what it won't do. And examples, this is critical. Examples are the single highest leverage thing you can add to a system prompt. Tools are how Claude reaches beyond text. Web search, database queries, code execution, API calls, file operations. Without tools, Claude can only work with what's in its context window. With tools, it becomes an agent that interacts with the world. The description field of each tool is as important as the code behind it. Claude reads the description to decide when and how to use the tool. Vague descriptions produce incorrect tool calls. Specific descriptions with examples of when to use them, and critically, when not to use them, produce reliable behavior. Claude Sonnet has a 200,000 token context window. That sounds unlimited until you're building a customer service bot that handles 4-hour support sessions, or a coding assistant that needs to hold an entire code base in mind. Context management is how you decide what goes in what order, and when to remove things. The anatomy of a well-managed context looks like this. System prompt first, always. Then any retrieved long-term memory relevant to this conversation. Then recent conversation history, most recent last. Tool results get summarized when they're too long. You don't need the full 10,000-line API response. You need the 3 relevant fields. Language models have no inherent memory. Every API call starts fresh. Memory in a harness is entirely your responsibility, and it's where most developers give up too early. You need 4 types. In-context memory is what's literally in the current API call. Temporary, expensive, lost when the context closes. External retrieval memory is a vector database. You embed information, search it semantically, inject the results into context when relevant. Key-value cache is structured facts. This user's name, their preferences, their account status. Episodic logs are the full conversation history stored somewhere persistent, indexed so you can retrieve past exchanges. This is prompt caching, one of the most underused features in the Claude API. If your system prompt is large and consistent across requests, caching it reduces cost by up to 90% and cuts latency by 85%. In production, at scale, this is the difference between profitable and not. Evals are how you know if your harness is working. Without evals, you're flying blind. Every change you make to the system prompt is a guess. With evals, every change is a measurement. Most developers skip this. They vibe check their prompts by asking a few questions manually. This is how you end up with a system that works great on the 10 cases you tested and fails on the 10,000 cases you didn't. Run evals on every change. Add a new few-shot example, run evals. Change a constraint, run evals. Switch model versions, run evals. This is engineering, not guessing. Safety isn't about preventing Claude from doing bad things. Claude already has strong built-in safety. It's about preventing bad things from entering or exiting your system through your harness. Prompt injection. Jailbreak attempts via user inputs. Malformed outputs that break your downstream code. Sensitive data leaking into logs. Validate input before sending to Claude and validate output before returning to the user. Check for length, prompt injection patterns, and sensitive data leakage. Here's the meta point nobody talks about. Claude Code, the tool I'm running inside right now, is itself a harness. The claude.md file at the root of every project is a system prompt. The permission system is a safety layer. The tool definitions for file reading, code execution, and web search are layer 2. The conversation history is context management. The memory system that saves facts across sessions is layer 4. When Anthropic built Claude Code, they built a harness. When you open a chat interface, you're using Anthropic's default harness. When you want Claude to reliably do something specific for your use case, code review, customer support, data extraction, document analysis, you need to build your own. Here's what a minimal but complete harness looks like. System prompt with identity and format. Tool definitions. Context with memory retrieval. Output validation. This is the foundation every production AI system is built on. That's it. That's harness engineering. Not one API call and a prayer. A structured system where every layer has a job and every failure has a place to be caught. The difference between a demo and a production system is exactly these 6 layers. The demo has the model. The production system has the harness. Every company that is genuinely extracting value from AI right now, not just running ChatGPT for email, as engineers who know how to build these systems. This is harness engineering, and it's the highest leverage skill in AI development right now. Not fine-tuning, not training, not model selection. Building the scaffolding that makes any model reliable, safe, and actually useful. We've covered the single model harness. But what about systems where multiple Claude instances work together? One that plans, one that executes, one that validates. That's multi-agent orchestration, and it's where harness engineering gets genuinely complex. Next video, we'll build a complete multi-agent system from scratch. You'll see exactly how agents hand off context, how you prevent infinite loops, and how you build eval suites for systems that behave non-deterministically.